we're on page 13 in the notes, and we're going to finish up section 10.2, dealing with angles in the unit circle. Next time, we'll start applying trig to all these angles and kind of tie everything together in this unit. The first thing we need to look at is how to convert between radians and degrees. And this is going to look very similar to the converting that you guys have done in chemistry. There's one conversion factor that we need to make use of. If we go all the way around the circle in degrees, that's 360 degrees. And if we go all the way around in radians, that's 2 pi radians. Our conversion factor we're going to need to use for everything is 2 pi radians equals 360 degrees. 2 pi radians equals 360 degrees. So we have some converting problems we need to do. In letter A, we're going to take 27 degrees and convert it to radians. The way that Mrs. Istvan, I think, does her conversions is she draws a long horizontal line, puts 27 degrees on the top, and then does something with the conversion factor there. I think the way Mr. Campbell and Mrs. Sherman do conversions with some ratios, we can say 27 degrees, and then we'll just multiply that by some other fraction. It's the exact same thing. It's just going to appear a little bit differently, but the calculations are identical. 27 degrees, I want to change that into radians, which means I need to put my degrees part of the conversion factor on the bottom and my radians part of the conversion factor on the top. I'm going to say 360 degrees on the bottom and 2 pi on the top. If you're using fractions and ratios, we'll put 360 degrees on the bottom and 2 pi on the top. Then we're going to multiply, and we'll get 54 pi over 360. Well, I should do some simplifying here. So ignoring the pi for right now, 54 over 360, well, I know they're even, so I know I should be able to divide by 2. I bet I can do better than that, though. I bet we can probably divide by 6 here. Yeah, we can. If you divide by 6, you're going to get 9 pi over 60. And actually, we can keep going. We can divide them both by 3, and we'll get 3 pi over 20. We're taking our 27 degrees. We'll multiply by the conversion factor with degrees on the bottom and radians on the top, and we're left with 3 pi over 20. I don't need to put units on my answer. If there are no units on an angle, it implies that it's in radians, which is what I want here. 250 degrees. Well, I'm going to set up my conversions. 250 degrees. I'm going to put 360 on the bottom and 2 pi on the top. 250 times 2 pi, that's 500 pi over 360. Let's see, 500 over 3. Actually, I know I can divide them both by 10, so I might as well take care of that right away. 50 pi over 36. I can divide by 2, so 25 pi over 18. And I think that might be it. 25 pi over 18. One more. You see what you can do with 108 degrees. If you pause the video and do some converting. Whoops, you can't see that. I'm thinking 9 pi over 15 for this one. Now we're going to go and convert some radians to degrees. In letter A, I have 3 pi over 8. So 3 pi over 8, that's radians. I need a radian conversion factor on the bottom, so I'm going to say 2 pi radians with 360 on the top. This is a pain. Let's not put a fraction like in just the numerator. Why don't I write that as 3 pi over 8, and then put the 2 pi on the bottom and the 360 on the top. Well, go and do some multiplying. 3 times 360. Oh, let me zoom out a little bit. 3 times 360 is 1080 pi On the bottom, 8 times 2 is 16 pi. Well, that's kind of nice. Those pi's are going to cancel. 1080 over 16. Maybe 135 over 2 degrees, or I guess a decimal might make sense here. 67.5 degrees. So you can't see that either. 67.5 degrees for that one. You try that next one. Negative 4 pi over 5. See if you can convert that. I push pause and see what you can do. And I'm getting negative 144 degrees. And here, don't forget that degree symbol. Without it, it means you're in radians. Oh, this last one looks weird. I want to convert 2. First of all, I know that this is 2 radians, because if it was degrees, it would have to have a little degree sign after it, and it doesn't. So even though it looks weird, whatever, I can still go. This is a radian thing, so I need my radian part of the conversion factor on the bottom. That's 2 pi. 360 degrees on the top. 2 times 360 is 720 degrees over 2 pi. Which I guess is going to become not the prettiest answer, but whatever. 360 over pi degrees. So we can use this conversion factor, 2 pi radians equals 360 degrees, to go through some lengthy calculations with these things. However, for the good angles around the unit circle, there's a quicker way we can do some conversions. First thing I want to do on page 14 is I want to fill in all the angles around my unit circle. And I want to do this in both degrees and radians. And if I can do this, it's going to actually make some conversion problems very easy. I'm going to start with 0 degrees, which is 0 radians. Coming up here, we have 30 degrees, which is pi over 6 radians. 45 degrees, which is pi over 4 radians. Then 60 degrees, which is pi over 3. Straight up, we have 90 degrees, which is pi over 2. Over here, that's 120 degrees, or 2 pi over 3. Then I have 135 degrees, or 3 pi over 4. 150 degrees, which is 5 pi over 6. And 180 degrees, which is pi. Continuing along down here, we have 210 degrees, which is 7 pi over 6. Then 225 degrees, 5 pi over 4. 240 degrees, which is 4 pi over 3. Straight down is 270 degrees, or 3 pi over 2. Coming over here, 300 degrees is 5 pi over 3. 315 degrees, 7 pi over 4. 330 degrees equals my favorite angle in radians, 11 pi over 6, the only one that's a 2-digit number up top. And if we go all the way around, of course, 360 degrees is 2 pi. If you need a moment, I would pause the video and make sure you have all of these measurements copied down, because we're going to use these to do some conversion problems. On the next page, on page 15, we're asked to convert these angles from degrees to radians using the unit circle. All that I mean by that is in letter A, 60 degrees. Well, I'm just going to find 60 degrees on my unit circle, which once you get this memorized, which will be very helpful for next year, and you will need to memorize this for next year, you'll just be able to picture 60 degrees is over here. And what is that in radians? It's pi over 3. I'm not going to show any calculations. I'm just going to say pi over 3. Go convert 135 degrees. Find that on the unit circle and just tell what that is in radians. It should be 3 pi over 4. Now, we have some negative angles. Negative 120 degrees. Well, zoom out. I know that 120 is over here. I know negative 120 is spinning the same amount in the negative direction, so it puts me over here at 240 degrees, which is 4 pi over 3. But I'm not going to call it 4 pi over 3, because 4 pi over 3 is the angle that starts here, spins like this, and ends up over there. I want to talk about the angle that starts here and spins clockwise to get to there. It's actually really easy. I was starting with 120 and just said negative 120, so my radian answer is going to be 2 pi over 3. I'm just going to call it negative 2 pi over 3. Negative 120 degrees is negative 2 pi over 3. Really? Just ignore the negative. Convert your 120 and stick a negative on your answer. You go convert negative 180. Should be negative pi. Radians to degrees, it's the exact same thing. Find the radian measure on the unit circle and tell the degrees. See what you guys can do right now in A through D. Pause the video, take a moment, see what you can do there. We should have 330 degrees. We should have 240 degrees. We should have negative 90 degrees. We should have negative 225 degrees. That's it. Now, if I asked you for an angle like negative 5 pi over 8, well, that's not a good one around the unit circle, and the only way we can convert that is by using our conversion factor. That 2 pi radians equals 360 degrees. But if it is a good angle, we can use the unit circle. Final thing we need to look at. We started on the first day by talking about coterminal angles in degrees, two angles that will end in the same place, but you get there in a different way. And we saw all we had to do was add or subtract multiples of 360. Well, if we're doing this in radians, all we need to do is add or subtract multiples of 360 degrees in radians is 2 pi. We are going to add or subtract multiples of 2 pi. So, in letter A, I want to find two angles, one positive and one negative, coterminal with 2 pi over 3. Well, 2 pi over 3 plus 2 pi and 2 pi over 3 minus 2 pi, or 2 pi over 1 and 2 pi over 1. Well, not super helpful, because to add fractions, we know we need to get a common denominator. What's 2 pi over 1 with a denominator of 3? Well, I can multiply the top and bottom by 3 to turn 2 pi over 1 into 6 pi over 3. I'm going to get 2 pi over 3 plus 6 pi over 3. And I'm also going to get 2 pi over 3 minus 6 pi over 3. And my two answers over here will be 8 pi over 3 for the positive one and negative 4 pi over 3 for the negative angle. All we're going to do is add or subtract multiples of 2 pi, which just means we may have to do it more than once. However, that's not going to be so useful initially. I'm going to need to get a common denominator, and then I can go from there. Well, over here, 7 pi over 4, I'm going to add or subtract 2 pi. And if you turn 2 pi over 1 into something with a common denominator, you're going to make that into 8 pi over 4. I need to go do 7 pi over 4 plus 8 pi over 4. And I need to go do 7 pi over 4 minus 8 pi over 4. Well, 7 pi over 4 plus 8 pi over 4, that's 15 pi over 4. 7 pi over 4 minus 8 pi over 4, that's negative 1 pi over 4. And those are my two coterminal angles. Negative pi over 6, I'm going to add or subtract multiples of 2 pi. See if you can figure out what that is as a fraction over 6. Hopefully you realize we're going to add or subtract 12 pi over 6 from this. So I'm getting 11 pi over 6. There's that favorite angle again. And negative 13 pi over 6. Last one. 5 pi over 2. Well, adding 2 pi over 1 is going to become adding 4 pi over 2 to this. 5 pi over 2 plus 4 pi over 2 will give me 9 pi over 2 for a positive angle. 5 pi over 2 minus 4 pi over 2 will give me 1 pi over 2, which is also good for a positive angle, but I know that I need a negative one at some point. So I'm just going to take that answer of pi over 2 and subtract another 4 pi over 2 from that. And I'm going to get negative 3 pi over 2. And we have our coterminal angles. In the homework, please make sure you're reading directions. Make sure if it says convert, you're converting. And make sure if it says find coterminal angles, you're doing this. If you take 2 pi over 3 and say, oh, that's 120, and that's the answer, that shows me you didn't actually read the directions, and I won't be able to give you credit for that part. So make sure you're doing what the problems are saying to do. Check out Google Classroom for the specific assignment.